Section 6.5, Applying Systems of Linear Equations. Essential question. How do you determine which method to use, graphing, elimination, or substitution, to solve a system? So in this lesson, we're going to be given a few different systems, and we have to decide which method would be the best to solve that system, and then we'll solve it afterwards. First, we're going to review all of the different solutions for a system of equations. So the three graphing possibilities are parallel lines, intersecting lines, and identical lines. Parallel, intersecting, identical. Parallel lines have no solutions. Intersecting lines have one solution. And identical lines have infinitely many solutions. If lines are parallel, they have the same slope and a different y-intercept. If lines are intersecting, they have different slopes. And if lines are identical, they have the same slope, same y-intercept. So just wanted to review that so you make sure you remember it. All right. So in your notes on the left-hand side, I want you to write, choose the best method to solve each system of equations. You don't need to write all the systems on the left, but I am going to have you fill them in on the right. Maybe pick 2 for each category, so you don't have to write every single one, but you should have 6 of them. 2 under graphing, 2 under substitution, 2 under elimination. All right, so graphing. It's easiest to graph if both equations are in slope-intercept form. If both equations are in slope-intercept form, then they're ready to graph. So we're going to look on the left-hand side for 2 equations that have y equals. So this one, that's in slope-intercept form. They both say y equals. This one is in slope-intercept form. They both say y equals. And this one is in slope-intercept form. They both say y equals. So I would pick 2 of those systems to write down, and I can separate them by a little line here too if that helps. The writing is kind of small. All right, for substitution, substitution is easiest if there's one variable by itself on one side. So for example, this would be a good substitution system because if I were to solve this, I look for the variable that's all alone, which is y. So I would circle the negative 2x plus 3. So remember when we always had our first step of drawing a circle, that was a substitution problem. So other ones where we have a variable by itself on one side is this one. I would be circling this. And let's see, is it this one? Yep, this one. I would be circling this. So I would write down 2 of those 3 systems. Then elimination, we have 4 remaining. Elimination works best when x and y are on the same side. So x and y are on the same side in both equations there. X and y are on the same side in both equations there. X and y are on the same side in both equations there. And here. So write down 2 of those. All right, let's get to the first example. You're just taking your notes on regular notebook paper, which is just fine. You'll notice we do have a graph on this one. You're only going to need to make 1 coordinate grid in your notes, so don't worry about getting graph paper. Just make the coordinate grid in your notes. So it says, choose the best method to use and solve the system of equations. This is going to be the same directions for all 3 examples. There's 3 examples in the notes today. So the 2 equations are y equals negative 3x plus 4 and y equals negative 3x minus 4. Now notice that both of these are in y equals or slope-intercept form, meaning that the best method or the easiest method to use would be graphing. So let's start by graphing the top equation, the red one on the right. So I'll take my red pen for the red equation. My y-intercept is what I graph first, which is positive 4. So I'll put a dot at positive 4. And then my slope is negative 3, or negative 3 over 1. And I would make at least a few dots. So I'm going to go down 3 over 1, down 3 over 1, down 3 over 1. And then I'm going to connect those with a line. Then my second equation I'll do in blue. I want to graph the y-intercept first, which is negative 4. So I'll put my first dot at negative 4 on the y-axis. And then I'm going to rise negative 3, run 1. Now you'll notice I'm getting to the bottom of my graph, so I'm going to go backwards. And I think I did one of those dots wrong. Let's see. 3 over 1. Oh, maybe not. Okay. So looking at those lines, they look like they're parallel. The way we know for sure whether or not they're parallel is they have to have the same slope, which if I look at the two equations, they both have a slope of negative 3, so yes, they are parallel. So I can write parallel, and parallel lines have no solutions. Remember, if they ended up being intersecting lines, you would need to name the coordinate point where they intersect. All right, next one. Negative 4x plus 3y equals 3, and 4x minus 5y equals 5. Make this a little bit bigger. Okay, so first I have to figure out which method would be the best to use. So if x and y are on the same side in both equations, the best method to use is elimination. So if I look at these two equations right now, I'm going to look and see if I have something to eliminate. And yes, I do. I have opposites right away. My opposites are 4 and negative 4. So I can cross those off immediately. Then I'm going to add 3 and negative 5, make negative 2. Negative 3 and 5 make positive 2. Break up my couple. And I'm left with y equals negative 1. Now keep in mind, we're not done. We're only halfway done with the problem. I have to take that negative 1 and plug it back into one of my equations. Usually I pick the top one, so I'll go with the top one. So negative 4x plus 3 times, and then instead of y, I'm putting a negative 1 equals negative 3. Bring down the negative 4x. 3 times negative 1 is negative 3. Then it's just couple and third wheel. My couple is negative 4x, so add the third wheel, the 3 on both sides. Negative 3 plus 3 is 0. Break up my couple. X equals 0. So that means this system has a solution of 0, negative 1. There is my answer. 0, negative 1. And the last one, x plus y equals 15, and x equals y minus 9. This one, I have one variable by itself on one side. That right there. The top one, x and y, are on the same side. Bottom one, they're on opposite sides. So that means I want to use substitution because I have one variable by itself on one side. So I'm going to circle what x equals, which is y minus 9. Since it's x equals, I'm going to plug it into x in my top equation. So I'm replacing this x with y minus 9. So y minus 9 plus y equals 15. And if it helps you, you can put 1's in front of the y's. So 1y and 1y make 2y. Remember, they're on the same side-like terms. Don't subtract 1y from both of them, you'll get 0. They're on the same side, add them together. Bring down the -9. Then you're going to add 9 on both sides, my third wheel. 15 plus 9 makes 24. Divide both sides by 2. And I'm left with y equals 12. So there's half of my answer. Now with substitution, I think the easiest thing to do is to plug 12 back into my circle for y, which is right there. You could do either equation, but the circle is the simplest one. So x equals, and then instead of y, I'm going to write 12. 12 minus 9 is 3. So the solution to my system is 312. Summary. So you are given 3 sentence starters for this summary. You should use graphing if both equations are in slope-intercept form. You should use substitution if one of the equations has a variable by itself. You should use elimination if both equations have x and y on the same side. The homework for this lesson is the 6-5 worksheet.